it was, I believe, a Thursday night. They contact our VP of development like 8 o'clock on a Thursday.
Welcome to Inside the Build, a podcast series that dives deep into how Forj Medical solves complex manufacturing challenges, told by the people whose knowledge, expertise, and ingenuity make Forj Medical the partner MedTech companies trust when the technology is complex and the stakes are high.
Hi everyone, I'm Mike Cook, and I'm a program manager with Forj Medical.
I'm Dan Hansen. I'm a new product development engineer.
And I'm Aaron Harpster, also a product development engineer with Forj Medical.
We're here to talk about one of our customers, which actually started out as one program, and with the success of that program, we turned it into multiple programs. So Aaron, would you like to talk about the beginning of coil winding that we started with this customer, and kind of we'll lead into how that evolved?
Sure. Yeah. The main topic of what we're going to be talking about is a very quick turnaround where we were able to save a device that was going through DV. An OEM was getting through, was starting DV, and a coil that they had, or a sensor really, it wasn't just the coil. A sensor was underperforming, and it was something that they had sourced from a different coil supplier. For whatever reason, it wasn't tracking in the system properly, and we had worked with this OEM before on an older product, and they ended up using that just kind of as like a placeholder to see if they had something that would work. They had a few of them in stock because they were still building these assemblies. And so they tried that and they found that it worked. And they came back to us and were like, hey, it was, I believe, a Thursday night. They contact our VP of development like 8 o'clock on a Thursday. They're like, hey, we need this. We basically need this coil, but we need it to look nicer. And some backstory on that, that sensor that we had developed previously was done with some older equipment that didn't have the resolution to effectively wind a nice coil consistently. The machine basically would guide the wire on with a stepper motor and a cam, and it was just too coarse with the control system that we had to allow us to get the right resolution on the wire guide. And so we would actually intentionally make it a messy coil because it was at least messy consistently. And that's why its visual characteristics were the reason why they didn't want to continue using it in this next gen device.
Yeah, I think it actually tracked okay, even though
it
didn't look very nice. It still tracked okay, but as I always say, aesthetics matter to a customer, even if functionally it really doesn't matter. There's an aspect to that that's really important to the customer. I think it brings like more trust from the customer into what you're doing and a sense of quality.
Especially in the medical device industry, when you have kind of the surgeons or doctors that are using these to perform. If you're a patient and you see something come out of a wrapping and it looks like a rat's nest or something like that, it doesn't feel, you don't feel as comfortable as something that's nicely packaged and comes out and actually has a nice look.
I mean, this was just a subcomponent, so it was all internal. No one would ever actually see it in the final device. But I believe there was also some durability issues just with handling at the time, like the way that we did the final assembly. You're more familiar with that, Dan.
Yep. Yeah, I think to Aaron's point, we got the new winders. It took us a little while, I think, to kind of understand the new winders, even with the higher resolution, and what we could do with them and how we were able to get coils that looked really nice. The winding looked, everything lined up correctly.
Yeah, consistent good winding. Because we were able to do, there was some experiments, even before I started, that were getting these older machines. I think they were built in the 90s. They're older than I am, which, I mean, I guess isn't saying much. But there was some experiments we were doing to swap out the cam and then get nice, consistent winds with this 58 gauge wire.
Yeah, we ended up basically doing like a DOE to kind of figure out how to best leverage this new technology to get.
So with this new technology and this more aesthetically pleasing wind, did we lose anything from a cost standpoint for the customer? Did the cost go up? Did the process become more long-winded and more challenging for the operators? I mean, you're taking something and making it better.
Yeah, it was because it was purely on the machine side, the bill of materials and what went into these kind of 2 generations of coils, the one that wasn't quite as nice and the one that looked better, was the exact same. So there was no real handling difference. The materials were the same. We were just running it on a newer machine. And one of the big things was actually some improved tooling. Anyway, back to the story of how we were able to actually to turn this around really quickly. I think that's actually a pretty good segue. I was a manufacturing engineer at the time, and we were doing some experiments. This is actually before we got the request for, hey, can you give us this thing you're already giving us, but make it look better? I was doing some experiments with some tooling to figure out how can we wind nicer coils consistently. And I figured a good stress test is this one coil that notoriously looks bad. It looks kind of like kite string, or like a spool of kite string. And so I just stress tested. I'll just recreate it one for one. I'll use the same parts and materials, same winding wire, same core, and just try out this different tooling. And I was able to get with some pretty solid consistency. It wasn't perfect. It was still prototype tooling. It was a QB pin with some features cut into it with an EDM, which worked. But so I had just basically developed the sensor just as a tooling test, and I had like 9 of them sitting at my desk in a tray, just kind of as a proof of concept. Then we get this call, and I'm pulled into the call because our actual coil development engineer at the time was out on leave on a motorcycle trip. So I get called in, and by the time I figure out what they're talking about, because our internal name for the part was different than what the customer was asking for, they referred to it as one thing, we referred to it as something else. And so I actually thought it was like a previous iteration. Anyways, once we figured that out, I'm like, guys, we already have the coil. And so then it was just a case of the final assembly, because the structure of how the coil was packaged with the twisted pair, with leading it out, with encapsulating it at the tip, that is also something that got improved.
Yeah, because I think the previous gen was packaged just in heat shrink, I think.
Yes.
Right?
Yeah. And so then,
so this next version was packaged inside of a polyamide tube, so you get a much more the form factor is a lot better for inserting into the barrel on the distal end of the device. Yeah,
you get a more consistent outer diameter, and it's just a more rigid assembly to work with. So we actually were able to improve the handling and the processing of this design while making it a more aesthetically pleasing product. It's not, we were using heat shrink and just the right amount of glue to try and build something that's almost cylindrical. We just start with a cylinder, put the coil in there, fill it with adhesive. It was a much better process. And with the winding as well, even though we're getting we ended up getting about the same units per hour, about the same yields, and there were fewer steps for the operators to do. We're able to switch from using a solvent bond on the coil to using a heat bond. The wire we were using was capable of a heat bond, but it wasn't something that we had experimented with before. So as part of this development process, we're able to include that. And now it's a standard thing with our coils. If we can, we're thermally bonding them, running hot air on the winder while it's running. And so by the time the winder is done, the coil is ready to be removed.
So we reduce the handling for the operators.
Yep.
Does that also reduce the skill that the operator needs in order to do this?
Yeah, somewhat.
Process?
It's not a huge improvement, but it is a little bit less.
There'll be less fallout during manufacturing.
Mm-hmm. Yeah, because previously you had to wipe a little bit of alcohol, IPA, on the coil, and that could lead to some damage. You could push wires out of the way while you're wiping it on. So it's just another step that we're able to skip, and that reduces the risk of scrap.
Perfect.
Yeah.
And then, so we have that new and improved way of winding, the whole assembly as well. What is that? What else did we improve along that manufacturing process?
I think before we talk about that, we should maybe talk about how we were able to quickly iterate back and forth with the customer. The customer, he didn't really know exactly what they needed, I think, at the time. So we had to come up with a matrix of prototypes and then quickly iterate through these prototypes, sending them to the customer quickly. He'll do testing. He'll kind of give a yay or nay, and just going through that iterative process quickly with the customer, and in tight communication with him as well, to really quickly narrow in on the proper configuration of the coil, I think is really important. And I think that's what he was really happy about, was just the coordination, the teamwork, and how quickly we're able to pivot, I think, in the project. Yeah. And finally come up with a good coil design. And then from there, like Aaron said, we're able to find a polymid tube to then insert it into, pot it. And we had a very durable product after that I think was also much more durable for the customer during their integration process. So I think it was a win-win for everybody. It was more manufacturable on our end, more durable during our processes, and more durable during their integration process.
Yeah. And the success of this project has actually, or this particular subcomponent, has actually led to future business with this customer. We did we're in the process of a next generation design for a kind of a similar product for them. This is a slightly shorter version of basically the same component, but there's still a lot of development that's gone into that. Dan has been very heavily involved in iterating on that next generation.
Yeah, it's been a long iterative process, even though they're relatively small changes. In medical device, you have to be obviously extremely careful during design and development, and working closely with the customer. But
Yeah.
we're almost to qualifications and almost to the finish line.
Yeah, and with this one, they're going to start ramping up one and start ramping down the other as well. So it's critical for us to understand from a manufacturing standpoint that we're going to put them both in the process at the same time, and make sure that we can manufacture them both with minimal impact to the production line. That'll definitely help with redundancy for the operators, the lead time for the product to be built, because it reduces the changeover time in between product lines, and it creates the stability for the facility that this does get manufactured in.
Yeah, for sure.
Yeah, I think it all just really highlights not only the teamwork and communication with the customer, but also the internal teamwork that, we all have with each other, and we work really closely with each other, which I think really helps with developing a better product.
Yeah, and with this customer and building that relationship, we started with one, are at two, and we're bringing back a third one to bring.
I've just started development on very, very early development, almost the proof of concept level of another variation on the same design. So getting the opportunity to continue with these early prototypes is one of the things that I really enjoy doing.
Yeah, I think we've developed a really good relationship with the customer, and I think they really, really appreciate that.
Yeah, and the vertical integration of being able to line the coils in-house and then complete the assembly is very key for the customer to have that same faith, because we have the design group, we have our manufacturing group, but then within that we have the different components that go into the subassembly as well that we can manufacture in-house. And so that keeps the customer's confidence in the quality and delivery of that product with a low cost, because we are keeping it in-house and not having to pay a component manufacturer to do that for us.
Yeah, and I think one of the big aspects that's really come into play is with the core material. We have all the equipment to cut it ourselves, so we're not relying on an outside supplier for cut cores. So anytime we get a request for, hey, what if we had this same product but a different length, we can just turn that around. Not quite same day. There is outside lead times with some of the thermal processing, but we're able to do very quick turnarounds that would normally take, upwards of months just to get the core material, because we have that capability in-house.
And with our coil winding becoming such a prominent thing here, we're moving this into different portfolios and different product lines, and this is allowing us to actually take and bring that stuff down to our Costa Rican facility as well, and work on those line transfers to make it a more profitable and cost-effective business line for our customers.
Yeah, I think having that flexibility is great. Doing development up here and then the customers can continue to manufacture their product in Minnesota, or if they want, they can move it down to Costa Rica or our Baton facility. So we offer a lot of flexibility as far as production.
Yeah.
This has been Inside the Build, podcast series by Forj Medical, where we're shaping the future of life-saving devices, one build at a time. Thank you for listening. For more information, visit us at forjmedical.com.